rectangular distributions also I have completed. Now another important, very important continuous time distributions, which is the normal distributions. Okay, so this normal distributions is also known as Gaussian distributions because it has been invented by German mathematicians, which is Gauss. And you are all very familiar with this name of Gauss in electrical engineering because of Gauss law, Gauss theorem, and a lot of electromagnetism's principles are there based on this Gauss, this mathematicians. So you see that these mathematicians, they play a very important role in both mathematics as well as physics. Okay, so this Gauss has also important algorithms for numerical techniques also for solving matrix equations, Gauss-Jordan elimination method. Okay, so now this German mathematicians Gauss has also has done a very rigorous analysis on statistical distributions, and they has a good number of work in the theory of error. Okay, theory of error and theory of approximations. So he proposed a probability density functions, and the probability density functions is written as this fx is equal to 1 by sigma root 2 pi e to the power minus x minus mu whole square divided by 2 sigma square. So this is the what has been done by the probability distribution functions of Gaussian distributions. Thank you. So fx is equal to 1 by sigma root 2 pi e to the power minus x minus mu whole square divided by 2 sigma square. Now this Gaussian distributions is also referred to as the normal distributions, and it has two important parameters, which is the sigma and mu. Okay, there are two important parameters in this probability density functions, where mu and sigma. Now we will actually see that this mu is the mean of the distributions. This mean of the distribution, that is the expectation of these distributions, is equal to mu. So mu is identified to be the mean of the distributions, and the sigma square is the variance of the distributions. So if I calculate the variance of these distributions, then the variance of these distributions will be equal to sigma square. So sigma is the standard deviation and mean is the mu. So these are also the two parameters of the distributions, and these parameters are equal to mean and standard deviations respectively. So we say that I write sometimes as x equal to capital N within bracket mu comma sigma square. So this means that x follows, the random variable x follows an uniform distribution. Now is important to identify or important to understand that any probability density functions, if wants to be a valid probability functions, then integration of minus infinity to plus infinity fx dx is equal to 1. So this has to be proved. So it can also be seen, it follows from your very standard mathematics. If you do this integration minus infinity to plus infinity fx dx, then it comes out to be equal to 1. Okay, this how I can say that the probability density function follows probability density functions is a valid probability density functions. Now, if I draw the picture of this probability density functions, then it is shown as shown in figure 3.2. So figure 3.2 shows you how the probability density function looks like, and you can see that it is a very good, well known, it's a bell-shaped curve. Okay, it's a bell-shaped curve and also known as normal probability curve. It is also known as normal probability curve, and there are certain important properties of these normal distributions which we will discuss one by one. Okay, so some of the, I will not go into the some of the proofs of these things, because the proof you can do it mathematically. Also, while I just give you these examples, give you some task to you to do these types of derivations. The derivations we will not go, rather we will just discuss about the important results, because the derivations of these things is a part of mathematical statistics, but those mathematics part we don't want to go in this particular class. Rather, I can give you just a hint at how these things are actually done. Now, to go for this normal distributions, if you want to do the derivations of these normal distributions, you have to have the knowledge of actually your gamma functions and beta functions. Beta functions and gamma functions, these are two, or the gamma integrals. These are the two important integrations, standard integrals, which are used in advanced calculus, integral calculus, and I believe that many of you are aware of this use of the gamma integrations of the gamma functions. Okay, so some results of the gamma integrations you need to review, and you need those gamma integrations if you want to derive this kind of normal distribution properties. Okay, so I am not going into the details of these properties, the derivations of these properties. I am just taking the important results of those integrations, of those calculations. But if you are interested, you may do it, and I can help you if you want to do these derivations. Definitely on a case-by-case basis. For if a particular student, if you want to do go into the rigorous derivations, then I can help you, but not within this class. Okay. Now let us see the various properties of this normal distributions. We see that the normal distributions is a continuous probability distributions of random variables, and a very important property, a very, very critical, important, very special property, that the mean, the mode, and the median, that means mean, median, and mode of a normal distribution graph, they coincides at the same point mu. So very important property, that the mean, median, and mode, they coincides and all equal to mu. That means mean is equal to median is equal to mode is equal to mu. Okay, this is a very important property, that if the mean, median, and mode, they coincides at the same point mu, it means that the graph is, the normal probability curve is perfectly symmetrical. It's perfectly symmetrical. So this is the second important property. The next property of this probability graph is that the variance, as I already told you, variance Vx is equal to mu2. Mu2 is the second central moment. That is, the second central moment is equal to sigma square. So second central moment mu2, which is also called as the variance, is equal to sigma square. So therefore, the standard deviations is equal to sigma. So here also you can do the derivations of this, your important property, involving the gamma integrations. I will say that some of you who want to do certain rigorous mathematics, they may please verify mathematically these results. Okay. So this is the third point. The fourth point is that the fourth property, the distributions is unimodal and bell-shaped. Unimodal means that there is only a single mode. You know, this mode means the point at the point of inflections where there is the highest probability. Okay, so the point at which the probability is highest, so or the maxima, that is called the mode. So you see from this graph that there is only one point of maxima, and therefore there is one mode of this graph, and therefore we call that the graph is unimodal and bell-shaped. Okay, unimodal and bell-shaped. And since the mean is equal to median is equal to mode, they coincides at the same point mu, and therefore the distributions is perfectly symmetric about mu. Okay, so if it is a perfectly symmetric about mu, then if I deviates a small distance x from mu in the left hand side as well as right hand side, so this value will be same. Okay, so if I go any distance at the left side or the right side and at the same distance at the left side, then these two values will be same. So f mu minus x is equal to f mu plus x. So if x be the amount of deviation from this mu in the right hand sides as well as the left hand side, then f mu minus x is equal to f mu plus x is equal to 1 by sigma root 2 pi e to the power minus x square by 2 sigma square for any value of x. So this shows that the graph is symmetrical. Okay, and as x tends to infinity, or as x tends x becomes higher in both the positives and the negative directions, we see that the graph comes very close to the x-axis, but it doesn't touch the x-axis. So we say that the curve is asymptotic to x-axis. তাহলে গ্রাফটা এখান থেকে আমরা দেখতেই পাচ্ছি, দেখো গ্রাফটা কিন্তু x-axis এর কাছাকাছি যাচ্ছে. It is very close to x-axis, but it doesn't actually it doesn't actually meet the x-axis. এইটা কিন্তু আমরা অনেক সময় আঁকার সময় ভুল করে থাকি. আমরা x-axis এর সাথে এটাকে ছুঁয়ে দিই. We touch this x-axis, but you have to be very careful but that in either positives or in the negative directions, the graph do not meet the x-axis. That means the graph is asymptotic along the abscissa. Abscissate দেখো asymptotic. So it is an asymptote. Okay, asymptote is also an important concept which you have you know in your differential calculus or integration calculus. If any of you come after BSc mathematics, or I don't know what is the level of your mathematics background, but those, if you have done a rigorous mathematics in the integral calculus or differential calculus, then asymptote, maxima, minima, and then all these things are covered in your undergraduate mathematics course. ঠিক আছে? সেই actually there is another branch of statistics which is called as a mathematical statistics. So mathematical statistics is a more applied mathematics, and there are lot of mathematical derivations are there. But as an engineer, we don't want to go into that portions of statistics where the mathematics are dealt with. Okay, আমরা যারা ইঞ্জিনিয়ারিং এর দিক থেকে ম্যাথমেটিক্সটাকে আমরা স্ট্যাটিস্টিক্সটাকে আমরা দেখি, we actually do the statistics as a tool for solving problems, statistics as a tools and techniques. But those who study statistics as part of mathematics, as part of their theoreticals or applied mathematics, they study more on the derivations, the mathematics of the statistics. স্ট্যাটিস্টিক্স এই জন্য দেখবে একটা আলাদা ডিপার্টমেন্ট হয়ে যায়, অ্যাপ্লাইড ম্যাথমেটিক্স এর আন্ডারে একটা আলাদা ডিপার্টমেন্ট হয়, ইন্ডিয়ান স্ট্যাটিস্টিক্যাল ইনস্টিটিউট একটা আলাদা ইনস্টিটিউশনস। সো দোজ পারসনস হু ডু দেয়ার statistics from a mathematics point of view, they are more interested on the mathematical basis and the mathematical rigor of this type of distribution curves, etc. But as an engineers, we try to focus more on the application of these statistical tools for solving certain engineering problems. So we don't want to go into the rigorous mathematics of these distributions. Okay. তাহলে এইখান থেকেও আমরা দেখতে পাচ্ছি that the curve is a asymptote to the x-axis. The distribution has points of inflections at x is equal to mu plus minus sigma square. X is equal to plus minus sigma. So point of inflection মানে হচ্ছে প্রত্যেকটা গ্রাফের একটা কার্ভেচার আছে। So this graph has a curvature. Okay. এরকম ছোট ছোট যদি অনেকগুলো পিস অফ গ্রাফ, এইটা যদি একটা যদি আমি এই জায়গাটা একটা ছোট গ্রাফ, এইখানটা একটা গ্রাফ, এইটাকে আরেকটু একটা সেগমেন্ট, if we consider certain small segments of graph, then we see that each of these small segment they actually changes its curvature. Okay, now this finding out the curvature of a graph, this is also another important topic in differential calculus. And how we do this curvature finding? If we want to find the point at which the graph changes its curvature, they are called the point of inflection. Okay, now the distributions, this particular normal probability integral, the points of inflection lies at x is equal to mu plus minus sigma square. And how do you find out those points of sigma square? I know that the differential derivative, the derivative is maximum or minimum, and the second derivative is equal to 0. So at the point of these inflections, the second derivative of the function is equal to 0. So if I put the second derivatives is equal to 0, and those solutions of these differential equations will give you the point of inflections at which the graph changes its curvature. And I find that it can be shown that the distributions has points of inflection at x is equal to mu plus minus sigma. Now it is another very important property. This is a very, very important property. This 8th number is a very, very important property in engineering applications. Okay. I find you know how to calculate the probability of x. As I told you earlier that the probability, if the distribution graph is been given, then the probability that capital X lies between 2 points A and B will be equal to the area of the density graph. Okay, as I told you that if the density graph is being given, then the probability that the random variable capital X takes values between 2 points A and B will be equal to the area of the probability graph in between the points A and B. Okay, so similarly, if there are 2 points x1 and x2 and the random variable x takes the values between x1 and x2, that will be equal to integration of fx dx in between x1 and x2. So fx will be replaced by 1 by sigma root 2 pi integration x1 to x2 e to the power x minus mu whole square by 2 sigma square into dx. Okay. Now এখানে একটা আমরা লেখার কিছু কিছু থাকছে না। পেন্সিল, তাহলে এইটা কি হলো, এইটা আমি বলতে চাইছি দ্য প্রবাবিলিটি দ্যাট x1 so this will be equal to 1 by sigma root 2 pi integration x1 to x2 e to the power minus x1 minus mu whole square by 2 sigma square into dx। এইখানটা একটা যদি আমরা ধরি যে এই জায়গাটা একটু আমি কষে দিতে চাইছি, t1 যদি ধরি x minus mu by sigma, এরকম যদি আমরা একটা ভেরিয়েবল ট্রান্সফার করি, দেন t1 will be এটা t1 না, t, তাহলে আমার কি হয়ে যাচ্ছে dt is equal to ঠিক আছে। নাও when x is equal to x1 সেটা হয়ে গেল t1, t1 is equal to x1 minus mu by sigma, আর t2 হয়ে গেল x2 minus mu by sigma, ঠিক আছে। সো this এইটা তখন কি হয়ে গেল, this is equal to, আমরা এটাকে লিখতে পারি 1 by root 2 pi 1 by root 2 pi then integration 0 to t2 e to the power minus t square dt e to the power minus t square by 2 dt minus zero to t1 to the power minus ঠিক আছে। চলো এটাকে আমরা তাহলে এইবারে এই যে ধরো this p of t 1 by root 2 pi integration 0 to t e to the power minus t square by 2 e to the power minus t square e to the power minus t square by 2 dt. AJ integration, this particular integration pt is equal to 1 by root 2 pi integration 0 to t e to the power minus t square by 2. This pt is called the probability integral. Okay, it's a very important integration in this theory. It's called a probability integral or error function. We sometimes also call this to be error functions. Error functions থেকে আবার আমরা এটা খুব একটা ইম্পর্টেন্ট, আমরা পরে দেখব। And these integrations, it cannot be computed, and we have certain, this actually can be computed numerically, okay? And the standard integrations, the analytical method is not there. We need to solve these integrations numerically, and the values of this integral, they are available as a normal integral probability chart, okay? Normal integral value chart. So in this theory of normal distributions, this particular chart, we have to be very much use that particular chart. Now here if this is be a generic formula, if x lies between x1 to x2, now if x lies between mu minus, if this x1 is equal to mu minus sigma and x2 is equal to mu plus sigma, okay, then utilizing these concepts and the probability chart, I find the probability integral chart is also given in your classroom. দেখবে ক্লাসরুমে কিন্তু দেওয়া আছে, that chart is, I have also given this chart in this classroom. So you have to actually use those chart to compute many of the numerical problems. Okay, then I find using that chart that this probability that the random variable capital X takes the values in between mu minus sigma to mu plus sigma comes out to be 0.6827. 0.6827. So তাহলে এক্ষেত্রে আমার এই ভ্যালুটা যদি আমি সাবস্টিটিউট করব, x এর জায়গায় মিউ মাইনাস সিগমা, হ্যাঁ, x এর জায়গায় আমি বসাবো এই যে x1, তাহলে x1 টা কি t1, তাহলে t1 টা আমার এক্ষেত্রে কি হবে, x এর জায়গায় আমি মিউ মাইনাস সিগমা বাই সিগমা বসাবো, আর t2 টা হয়ে গেল এক্ষেত্রে মিউ প্লাস সিগমা, তাহলে t2 টা কি হবে, মিউ প্লাস সিগমা মাইনাস মিউ ডিভাইডেড বাই সিগমা, আর এই পয়েন্টে কি হবে, t1 ইজ ইকুয়াল টু মিউ মাইনাস সিগমা মাইনাস মিউ ডিভাইডেড বাই সিগমা। বুঝতে পারছো? করে যদি আমি এই ইন্টিগ্রেশনের এই জায়গাটাতে আমরা পৌঁছলে সেই চার্ট থেকে আমরা এই রেজাল্টটা কিন্তু পাচ্ছি। সো I find that this probability that the random variable x takes the value between this mu minus sigma to mu plus sigma is 0.6827, between mu minus 2 sigma to mu plus 2 sigma, তাহলে এইখান থেকে এইখানে হচ্ছে 0.3413 আর এইটা হচ্ছে 0.3413, তাহলে এই টোটালটা হয়ে গেল তোমার 0.6827. ওকে, so in between this mu minus 2 sigma to mu plus 2 sigma, অর্থাৎ এই পয়েন্ট থেকে এই পয়েন্ট, তাহলে আমরা যদি যোগ করি 0.1359 plus 3.13 plus 3.13 plus 1.1359, it comes out to be 0.9545. Similarly, between mu minus 3 sigma to mu plus 3 sigma, অর্থাৎ এই পয়েন্টটা থেকে এই পয়েন্ট অবধি, it comes out to be 0.9973. So therefore, although are normal variables, they can theoretically take any value from minus infinity to plus infinity, but practically the sample values lies, all of the sample values, they lie between plus minus 3 sigma limit, plus minus 3 sigma limit. So this is the mu minus 3 sigma and mu plus 3 sigma is known as the effective range of the normal variables, because 99.73% of the sample values lies within between these effective range, and other beyond that point, since it is asymptotically tends to 0. তাহলে দেখো ডেনসিটি ফাংশনটা it is asymptotically tends to 0 as x extends beyond minus 3 sigma plus minus 3 sigma limit, but it never becomes equal to 0. It asymptotically tends to 0 as x extends beyond plus minus 3 sigma limit. So now this is a very important practical applications in engineering designs, and we call the reliability engineering. Okay, the concepts of engineering reliability, the reliability of any electronic products, the reliability of any transistors, the reliability of any electronic circuits, or the reliability of any semiconductors or any communication link or any engineering systems. The reliability graph is basically a normal distribution graph. Okay, and this plus minus 3 sigma limit determines the internal quality of the distributions. তার মানে এই 3 sigma value should be certain fraction of its mean. তার মানে কি 3 sigma value আমরা সব সময় has to be a very small fraction of mean. তার মানে কি হচ্ছে 3 sigma by mu, or 3 sigma by mu should be say 5% or 10%. It should not be greater than that. You also know from your statistic that the sigma by mu is referred to as the coefficient of deviation. Okay, so this sigma by mu is also known as the coefficients of deviations. এবং একটা good process, একটা engineering process, সেইটাকে আমরা ভালো বলবো, we'll call a good process if the 3 sigma value is less than 10% of mu. Okay, and a process will be called a bad if the 3 sigma value is greater than the 10% or 15%. Okay, because the reliability graph follows an uniform normal probability density graph, and you see that this 3 sigma limit, within this 3 sigma limit, 99.73% of the samples they actually follow. So the good engineering process should not have high 3 sigma value. The 3 sigma value should be as small as possible, and within 10% of mu will be considered as a good engineering process. বুঝতে পারছো? Is it clear to you? বুঝা গেল কি?
Yes, sir.
আর একটা yes sir শুনলাম।
হ্যাঁ স্যার বুঝে গেছে।
দুটো?
হ্যাঁ স্যার ঠিক আছে। হ্যাঁ স্যার বুঝেছি।
বাহ, ভেরি গুড।
Yes, sir.
বোঝা যাচ্ছে। আচ্ছা, তাহলে তারপরে পয়েন্টগুলো আমরা এখানে আসছি, এটা তো খুব বুঝতেই পারছো, the coefficient of skewness is equal to 0 because it is always symmetric. So it is, since it is a perfectly symmetric graph, so the coefficient of skewness is equal to 0. সেটা গ্রাফ থেকে আমরা দেখতে পাচ্ছি। And the coefficients of kurtosis, that is also equal to 0. It is the distributions is always mesokurtic, and hence the thickness is ideal. So I find that the coefficient of skewness is equal to 0 and coefficients of kurtosis is also equal to 0. So the distribution is always mesopartic. আচ্ছা, এইবার একটা এই পয়েন্টে আসি। Now if I this particular distributions this particular distributions is symmetric around the mean. Now if the mean is equal to 0, if I consider a case that the mean is equal to 0 and the standard deviations is equal to 1, or the variance is equal to 1. Now if I consider a very special case of this normal variable of this uniform distributions where the mean is equal to 0, that means it is symmetric around the 0. Okay, so it is positive at the right hand side and negative at the left hand side. If the graph is symmetric around 0 and the variance is equal to 1 or the standard deviations is equal to 1, that means the E of, let us consider another random variables where z is equal to x minus mu by sigma with E of z is equal to 0 and V of z is equal to 1. Then such type of random variable, this z is known as standard normal variate or normal deviate. Then z is called as the standard normal variate. Okay, standard normal variate, and therefore the probability density function of z, the probability density function of z is equal to 1 by root 2 pi sigma square টা এখানে 1 হয়ে গেল sigma, so 1 by root 2 pi e to the power কি ছিল x minus mu whole square by 2 sigma square, তাহলে mu টা 0, তাহলে এখানে হয়ে গেল x minus mu whole square এর জায়গায় আমি লিখলাম e to the power minus z square, আর sigma square যেহেতু 1 তাহলে 1 by root 2 pi e to the power minus z square by 2, but z can extend from minus infinity to plus infinity. And the distributions is given as z equal to n capital N 0,1. Okay, বুঝতে পারছো? Now if I calculate the cumulative distribution function of z, so the cumulative distribution function of z is, let us suppose phi of k. So phi of k is equal to the probability that z takes the value less than equal to k. এটা আমরা cumulative distribution functions এর definition থেকে জানি, that phi capital F দিয়ে যেটা আমি ওখানে বুঝিয়েছিলাম, ঠিক আছে? So phi of k is equal to the probability that z less than equal to k. So this is equal to integration minus infinity to k g dz. বুঝতে পারছো? And these integrations, these integrations is available in the statistical table, because this integration টা কিন্তু এরকমই একটা ইন্টিগ্রেশন যেটা আমি আঁকলাম, এই যে একই রকমের ইন্টিগ্রেশনস হবে। দেখো এই যে 1 by root 2 pi e to the power minus z square by 2, তাহলে আমি এখানে কি করেছি দেখো e to the power minus t square by 2, ঠিক আছে? So this probability integral is available in the normal table. So this particular functions integrations is also available in the statistical table for different values of k. তাহলে আমরা এখান থেকে দেখতে পাচ্ছি that, see how qualitatively, pictorially this can also be visible. So integration minus infinity up to k. So this is the density graph for a normal variate, because this normal variate, it is symmetric around this 0 and it extends as minus infinity to plus infinity, and the probability that z less than equal to k, তার মানে z k এর অবধি, z minus infinity to up to k point অবধি, তাহলে কি হবে, that is equal to the area of the area of the density graph up to k। তাহলে এই যে পুরো যেটাকে এখানে আমি হ্যাশ করে দেওয়া হয়েছে, এই পুরো এরিয়াটার যেটা সাম, এরিয়াটা হচ্ছে তার ইন্টিগ্রেশন। সো the summation of this graph or the area of this graph shows you this minus infinity to k gz dz। বুঝতে পারছো? Now it's another important property, phi of minus k. So phi of minus k means the probability z less than equal to minus k, তার মানে এই k পয়েন্টে যদি মাইনাস k পয়েন্টে হয়, তাহলে phi of minus k অর্থাৎ কিউমুলেটিভ ডিস্ট্রিবিউশন ফাংশনটা কত হবে, কিউমুলেটিভ ডিস্ট্রিবিউশন ফাংশনস will be minus infinity to minus k, z less than equal to minus k, তাহলে minus k অবধি এই জায়গাটা। Now z less than equal to minus k probability, it is, we can write it as p z greater than equal to k, okay, z greater than equal to k, simple logic থেকে আসছে। এইবারে দেখো the probability z greater than equal to k, অর্থাৎ এই পার্টটা z greater than equal to k, k এর থেকে বড়, k এর থেকে বড়, তার মানে এই জায়গাটা দেখো এটা সিমেট্রি থেকে ফলো করছে, বুঝতে পারছো? এইখানে যা এরিয়া হবে obviously এই পোরশনটার তাই এরিয়া হবে। Now total area will be equal to 1. You know that the total area will be equal to 1. So this probability z greater than equal to k will be equal to 1 minus p z less than k. So p z greater than equal to k will be equal to 1 minus p z less than equal to k. So phi of minus k is equal to 1 minus phi k. So this is a very important property. এটা কিন্তু একটা ভীষণ ভীষণ ইম্পর্টেন্ট প্রপার্টি, এটা আমাদের প্রচুর কাজে লাগবে। Henceforth we'll see that phi of minus k is equal to 1 minus of phi k, and therefore phi of 0 point, তাহলে আমি কত দেখছি, phi of 0 is equal to 1 minus phi of 0. So 2 phi 0 is equal to 1 or phi 0 is equal to 0.5. বুঝতে পারছো?
হ্যাঁ স্যার,
ভেরি ইম্পর্টেন্ট থিং। তারপরে দেখবে তোমরা এগুলো একটু দেখবে, p z less than equal to x less than equal to x কি হবে, p x greater than equal to b হলে কোন জায়গাটায় হবে, আর এইটা একটা ইম্পর্টেন্ট প্রপার্টি, that if p the probability that x lies between a and b will be equal to integration a to b fx dx equal to এইরকম একটা জায়গা পাবে। ঠিক আছে, এটা তোমরা নিজেরা করবে। আজকে এই অবধি থাক, আর নেক্সট দিনকে দু একটা অঙ্ক করে আমরা দেখাবো যেটা কি করে আমরা অঙ্কগুলো করি। হ্যাঁ, প্রবাবিলিটি চার্টটা ধরে দেখিয়ে দেবো যে হাউ উই উইল ইউজ দিস প্রবাবিলিটি চার্ট টু কম্পিউট দ্য প্রবাবিলিটি ইন্টিগ্রালস। বাট ইউ প্লিজ ডু দ্য নেসেসারি ব্যাকগ্রাউন্ড থিওরিটা ভালো করে এখান থেকে করে রাখবে। আজকে আমরা ডিসকাস করলাম, নেক্সট দিন since this is a very important topic, next thing we will work out certain but discuss some application of this probability distributions, normal probability distributions. ঠিক আছে, কিন্তু তোমরা বাকিটা নিজেরা করবে। কেউ একটু তোমরা তো একটা রাখছো, আমি ক্লাসরুম